So question 1, explain the difference between a physical change and a chemical change and give examples. Well, a physical change does not produce new substances. So a physical change just retains the original substance that you had. So when freezing liquid water to ice, the first substance is H2O, and ice is also made of H2O, so nothing's changed. In a chemical change, the substance is actually changed and no longer exists. So for instance, the substance composition is now different from when it started. So in burning coal, carbon, C, is changed into CO and CO2 by combining it with oxygen. Okay, so you no longer have C and O by themselves. You now have CO and CO2, which are different, obviously, to O and C. And that's the difference between a chemical and physical change. Identify which of the following reactions is a physical change and which is a chemical change. Justify your choice. Okay, so you've got dot, square, dot, plus 2 circles gives you circle, square, circle, and 2 dots. And then you've got square, circle, plus triangle, dot, goes to circle, square, and triangle, dot. So A is a chemical change, while B is a physical change. In A, the arrangement of components is changed, indicating a chemical change. So what that means is, essentially, you've got these dots and these circles, and you see they're rearranged now. These lines connecting them are all different. So you've changed the chemicals, essentially, into new chemicals on this side. So it's a chemical change. Now in B, the composition of chemicals is unchanged, indicating a physical change. So you can see the triangle and the dot are still present. Okay, so these two are still present. But the square and the circle have just been flipped around. So they're still exactly the same thing, just you've gone from here to here. Okay, so you've just done this. So obviously they're the same substance. So nothing's happened. So it must be a physical change. Maybe it became a gas, or maybe it became liquid, stuff like that. So you can see that's how we sort of diagrammatically represent a chemical and physical change. So the main indication that a chemical change has occurred is the production of a new substance. Identify 3 observations that would indicate that this has occurred. Okay, so what are the 3 ways to know a chemical change has happened? You've got a permanent color change. So the color has gone from one to another. For instance, silver chloride turns into silver and chlorine. One is black, one is white. That's pretty obvious that the color has changed. There's a gas produced. Now we're going to go through a question on that, and we're going to come back to what that actually means and how do we be a little bit more rigorous with this particular criteria. A precipitate forms from 2 liquids. So you pour 2 liquids together and you get a nice solid all of a sudden. A solid disappears. Again, there's a bit different here as long as, like, if you're dissolving it in liquid, there is a subtle difference here with a physical change. And heat and light are produced or absorbed. Okay, so those are some common ways of knowing that a chemical change has occurred. Okay, explain the difference between chemical and physical change with respect to the particles within the system. Okay, now we're going to look at a more physical, or try and explain what is actually happening physically inside each of these systems. Well, in a physical change, the bonds between the particles are being influenced. So the bonds between particles are the ones that are being changed. The particles themselves remain unchanged throughout the process. So the particles are happy to just move around. Your reaction will just sort of just shift them around a little bit or give them more space to move, something like that. In a chemical change, the bonds within the particles are separated and the new particles are formed from the same components. So the particles themselves are broken up into their components and put back together in a different way, and that's a chemical change. Okay? So an indicator to detect chemical changes is the production of a gas. Explain why this may not be a good criterion and propose a more suitable test. Okay, so now we're going to talk about this gas thing that I've been going on and on about in this whole lesson. So why is it not a good criteria or criterion to use when we're trying to figure out if it's a chemical or physical change? The production of a gas can occur in some physical changes as well as in chemical changes. Now you're thinking, oh, well, give me an example because I don't understand what you're talking about. So if I boil water, I'm actually producing a gas, aren't I? I'm turning liquid water into gaseous water, okay? But I know that's a physical change, but I just said that chemical changes can often involve the production of a gas. So now we're in trouble, right? There's ambiguity, essentially, in this question. So obviously it's ambiguous, and thus a better criterion should be used. A better criterion that we could use is the evolution of a gas with different chemical properties to the original substance. So it has to have different properties to the substance that you started with. So obviously steam has the same chemical properties as water, but hydrogen obviously has different properties to hydrochloric acid and zinc. So you can see that that's a much better, much more rigorous definition or criteria to use, rather than just saying, look, any gas produced means it's a chemical change. Okay? So that concludes today's lesson on physical and chemical changes. We looked at what a physical change is, what a chemical change is, and how do we identify both. Okay? So I look forward to seeing you at our next lesson.